In this demonstration, we're going to look at the trade-off between sensitivity and specificity. And we're going to look at something known as a receiver operator characteristics, the ROC. So there's a lot going on here, but to start, let's just look at this table here. I talked about audit C before, which is a score, a questionnaire that leads to a score and helps us identify people at risk with drinking, or risky drinking, or in this case, I'm just going to call it hazardous drinkers. Okay. This is data from a cohort of individuals who filled out the audit C score or the audit C questionnaire. But in this case, I have them already classified as hazardous drinkers or non-hazardous drinkers. So I sort of already know the truth about them, whether or not they're hazardous or not. So what this table tells us is that among the individuals that scored 1 on audit C, 10 were actually hazardous drinkers and 200 were not hazardous drinkers. Among the people who scored 8, 35 were hazardous drinkers and 73 were not hazardous drinkers. You can actually score 0 in audit C, but I didn't include it here just for succinctness. Okay. The question now is, if I force myself to say that we want to have a cutoff, we want to say that individuals with a score on audit C on a specific level or higher are hazardous drinkers. So I really want to change this score into hazardous or non-hazardous. Which cutoff should I pick? Here, I'm going to show you the result of picking 0. So if I say that individuals with a score greater than 0 are hazardous drinkers, what happens? Well, everybody's a hazardous drinker then, because everybody scored greater than 0. So we get perfect sensitivity. Of the people who were hazardous drinkers, all of them tested positive. But specificity is terrible, because of all the individuals who were not hazardous drinkers, all of them tested positive for being a hazardous drinker. So cutoff 0 might not really get us where we want to be. What if I increase this to 1? Okay, something happens. Now, 10 individuals who were hazardous drinkers did now not test positive, but 350 did. So the sensitivity is still pretty good. The specificity is a little bit better than before, because now there were 200 individuals who were not hazardous drinkers who were also told that they were not hazardous drinkers. They tested negative. And as we continue up, you're going to see how, let's see, we go to here, 5. The sensitivity is 0.75, specificity 0.682, so they're sort of balancing each other here. As we continue, specificity gets better than sensitivity. At 8, for instance, the specificity is now 0.9, while sensitivity is 0.4. And if we go to the other extreme where we say, well, you have to have a score greater than 12 to be a hazardous drinker, well then nobody's a hazardous drinker. So the sensitivity is 0, while the specificity is 1, or 100%, because everybody is told that they're not a hazardous drinker. So now the question is, well, what cutoff should we pick? In reality, you could, and we're going to do that here. I'm going to show you how to sort of pick the cutoff which balances sensitivity and specificity. But in some cases, you might actually care more about sensitivity, or you might care more about specificity. However, this ROC diagram shows you the trade-off. So I'm going to click that box here, and we're going to get the ROC diagram. So what this tells you is you have sensitivity on this axis, and you have 1 minus specificity on this axis. And that's just a trick because you want to have the axis go so that up here is where perfect sensitivity and perfect specificity is. So ideally, we'd like to be up here. And which cutoff gets us closest? Well, maybe somewhere here, 6, 5, 4, in this area here. That gets us as close as possible to up here, which would be a perfect sensitivity and perfect specificity. As you saw before, if we set the cutoff to 0, then we'll have a perfect sensitivity, but we'll have a terrible specificity. And if we set the cutoff to 12, we'll have terrible sensitivity, but a great specificity. And so this RSC curve could visualize for you this trade-off between sensitivity and specificity given different cutoffs. But as I said, maybe it's not always the case that you want to pick the one that balances these perfect. So for instance, for audit C, the most common cutoffs are around here, 3 and 4. Okay, you can play around with this to see how this changes. And also, I didn't mention that. I did mention that you have external constraints in different contexts that will probably dictate if you care about sensitivity and specificity, but also one of them is also going to be how costly it is to actually have a false positive or false negative. And those two don't really cost the same in all contexts.